Okay, so what you've been given here is piecewise functions. What that means is there's like two different pieces of it. Earlier when you were doing domain and range questions, remember a function was only good for a certain domain, and then it would give out a certain range. In this case, we're given specified domains that we're allowed to use these functions for. And the reason it's called piecewise is because basically there's as many pieces as there are functions. So here in your first function, you have f of x equals, and they put this parentheses to say, look, this is the same function, but now we're going to have two different rules depending on what domain we're in. So it's equal to x plus 1, which just is the line y equals x plus 1 that you're used to, okay? And that's going to be true if x belongs to the set negative infinity to 2. So just like you were talking about domains. And now notice here that 2 is not included. Okay, we've got the soft-sided 2. And then it's going to be equal to x plus 3 if x belongs to the set 2 to infinity. So now we've gone from negative infinity to infinity. At the point we reach 2, we stop listening to x plus 1. And when we get to 2, we go down here to this one. Okay? So when it says, what is f of 0? Well, f of 0, 0 lives between negative infinity of 2. So I'm going to follow this rule when I'm thinking of f of 0. So therefore, f of 0 is going to be equal to 0 plus 1, the first function, because it's in that domain. So it equals 1. Okay? The second question says, what is f of 10? Okay, so f of 10, again, all I have to do is turn around and see where am I existing. Well, 10 lives between 2 and infinity, so I'm going to use the second function. So I'm going to get, 10 plus 3, which equals 13, okay? And then last but not least, if we've got the, what is f of 2, okay? Here's the only tricky part, because this is your boundary point. But looking at our notation, 2 is not allowed to be in this function. However, it is allowed to be in this function. So this is where I use 2, and it's going to be in that x plus 3. So it equals 2 plus 3, which is equal to 5. Okay? Now, what we want to do is be able to graph this function. So I'm going to erase this real quick here. Okay? And basically what it is just like when we used to graph inequalities. When something could equal something, we had a solid dot. And when it couldn't equal it, it was an open dot. That whole thought process is going to come back. So if we're graphing x plus 1 from negative infinity to 2, that really is just the line y equals x plus 1 that we started graphing back in 6th grade. It means that we have a y-intercept of 1, okay, and then we have a slope of 1. So we're going to go up 1 and over 1, okay, and that's, notice I'm at 1. And then over here at 2, when I go up 1 and over 1, I'm going to put an open dot there, okay? So I've gone up my 2 points, okay? So from my first step, these are all good included points. This one is no longer included, but this line is good from negative infinity to 2. So that means I'm going to go down backwards like this, all the way to negative infinity. Over here for the next one, it says when it equals 2, we're going to be at x plus 3, okay? Well, we need to move this up to 5, so I hate to write through the middle of this. So again, this is a big picture of what's going on. I'm going to make a smaller picture so we can actually gather it. And in fact, I'll use a little more quadrant 1. So 1, 2, 3, 1, 2, 3, 4, 5, 6. In fact, 4 and 5. Okay, so we had this one, then we went up 1 over 1, and up 1, and we had the open dot here, and then here is that line that we just had. Okay? And then over here, we have some more x values. And again, noting that right above 2 is where I'm no longer listening to this function, but I'm going to go to this function. Well, when x is 2, and I add 3, I need to start up here at 5. So directly above it, I have a solid dot, and now I still have that slope of 1. So I would still look like this. Notice this makes 2 pieces, hence the name piecewise function. And we still pass the vertical line test. That's why this still is a function. Because at 2 we exist here, but we don't exist here. So if you passed a vertical line through here, it technically wouldn't touch at any point. Once it stops living here, it immediately picks up there. As infinitely close as you want to get to 2 from the left side, so 1.999999 forever, is going to live right before this open hole, and everything just closer, or actually right at 2, lives on this line. So we never have a gap in values, but we jump. There's a hole in the graph from here to here. First piece, second piece,